purpose of this problem is to determine overhead allocation under activity-based costing as well as traditional costing. We're also given a situation on a particular job estimate and asked to calculate the cost per unit under activity-based costing and traditional costing. We're told that this company designs and builds factory-made premium wooden stairways for homes. The manufactured stairway components permit installation of stairways of varying lengths and widths. All are made of white oak. We're told the budgeting manufacturing overhead costs for 2017 are as follows. And what we see here is that we're told the total budgeted overhead costs as well as the cost pools and amount allocated to each pool that would be used if we were using activity-based costing. For the last 4 years, the company has been charging overhead to products on the basis of machine hours. For the year 2017, 100,000 machine hours are budgeted. The owner-manager of the company recently directed his accountant to implement the activity-based costing system that he has repeatedly proposed. At his request, Bill and the production foreman identify the following cost drivers and their usage for the previously budgeted overhead cost pools. So again, in the top box, we're told the total amount of overhead costs that was allocated to each pool, and then related to those pools, we're told the cost driver for the pool and the expected use of cost drivers. So for example, the purchasing pool has $75,600 allocated to it. We're to use the number of purchase orders as the cost driver, and the total annual expected use of that driver, the total number of purchase orders, is expected to be 600. The sales manager has received an order for 250 stairways from Community Builders, a large housing development contractor. Bill has prepared cost estimates for producing components for 250 stairways so Steve can submit a contract price per stairway to Community Builders. He accumulates the following data for the production of 250 stairways. So what we see here is the estimated amount of materials, labor, machine hours, and direct labor hours to produce those stairwells. And we're also then told the expected use of each cost driver under activity-based costing to produce 250 stairways. The first part of this problem asks us to compute the predetermined overhead rate using traditional costing with machine hours as the basis. So to do this, we'll take the total budgeted overhead costs of $1,175,540 and divide it by the total estimated machine hours, which is 100,000 machine hours, and that gives us a rate of 11.76 per machine hour. That is $11.76 per machine hour. The next part of this problem asks us what is the manufacturing cost per stairway under traditional costing. So to do this, we see that the direct materials cost would be $104,200, and the direct labor cost would be $112,100, and then for the overhead, we will take the estimated machine hours to produce 250 stairways, which is 15,000, times the rate that we calculated above, which is $11.76 per machine hour. So 15,000 machine hours times $11.76 is $176,400. So the total cost to produce the 250 stairways is estimated to be $392,700, and then for a cost per stairway, we'll take the $392,700 divided by the number of stairways, which is 250, and we get $1,570.80. The next part of this problem requires that we calculate the activity-based overhead rate for each activity. So to begin, we can see that for the purchasing pool, the cost that was allocated to the pool was $75,600. We'll divide that by the total number of estimated cost drivers for the pool. In this case, the cost drivers for the purchasing pool is the number of orders, and it's expected that for the year there will be 600. So we'll divide 75,600 by 600, and we get a rate of $126. Next, for the handling of the materials, we take the cost of $82,720 divided by the number of moves, which is 8,000, and we'll get a rate of $10.34. Next, for production, the cost is $217,000. We divide that by the cost driver, which is direct labor hours. It's estimated to be 100,000 direct labor hours, so we get a rate of $2.17. Then we have the setup of machines, which is 97,500, divided by the number of setups, which is 1,250, is a rate of $78. Then inspecting, $120,000 divided by the number of inspections, which is 6,000, gives us a rate of $20 per inspection. Next is the inventory control pool, a cost of $132,720 divided by the number of components, which is 168,000, gives us a rate of 79 cents. And then finally, the utilities pool, a cost of $450,000 divided by the number of square feet, which is 90,000, gives us a rate of $5. The next part of this problem asks us to calculate the total overhead assigned under ABC. This would be for the job estimate to prepare 250 stairways. So it's estimated, for example, that the number of purchase orders for this job would be 60 purchase orders. So we take the number of purchase orders of 60 times the rate that we calculated previously of $126 per purchase order, and that would give us 7,560. Then we take 800 material moves times the rate per move of $10.34, and we get 8,272. Production, we would take the number of direct labor hours, which is 5,200, times the rate of $2.17, is 11,284. Then for the setup pool, we take the number of setups, which is 100, times the rate of 78, gives us 7,800. Then inspecting, we take the number of inspections, which is 450, times the rate of $20 per inspection, is 9,000. Number of components is 16,000 components times the rate of 79 cents per component, 12,640. And finally, the utilities, we take the number of square feet occupied for this job of 8,000 times the rate of $5, gives us 40,000. The total then would be 96,556. The next part of this problem asks us, what is the manufacturing cost per stairway under the proposed activity-based costing? So to do this, we will add together, first of all, the materials, labor, and overhead. So the materials we can see is 104,200, so that's materials. The labor is 112,100, and the overhead we calculated is 96,556. The sum of those three then is the total estimated cost of this job, which is $312,856. We then can divide that $312,856 divided by the number of stairs is the cost per stair, which is $1,251.42. So that's our answer, $1,251.42.